All right. Let's continue right along. So the last lecture we looked at the 6 trig functions. You remember them, right? Sines, y, cosine, x, tangent, y over x, cosecant, 1 over y, secant, 1 over x, cotangent, x over y. Pretty good, right? I remember those. All right. And then we took those 6 trig functions and we said we could find the value of those functions based on quadrantal angles. So the quadrantal again being 0, 90, 180, and 270 because you're actually not in a quadrant, you're on an axis. Well, we can actually find multiples of these angles because if you remember, when you go all the way around this circle, so 1 revolution we know is 360 degrees, but in radians is 2 pi. Kind of try to think more in radians, okay? And so if I want 3 pi, well, I remember 180 degrees was pi, so I just have to go a little bit more, and then I'm back here. Why do I care? Because now I have a point. You always wondered, does she really have a point? I have a point that I can now use to find the 6th trigonometric function. This example over here is just showing you that if it's a negative angle, okay, that you're going in the negative direction. So don't forget that when you have negative angles. All right, so moving right along. If I want to find the exact values, however, of these trigonometric functions of an angle that's not a quadrantal angle, how would I do that? I'm going to tell you. So if I take the line y equals x, and you need to convince yourself that cuts this quadrant right in half. So if to up here is 90 degrees, then in half would be 45 degrees, right? Right. So I want to figure out what these values are. And I could do that by that smart old Pythagoras dude. I could say, well, here I actually have a triangle. This length is x. This length is y. And that nice old dude said that x squared plus y squared equals r squared. Well, because I just said this line is the line y equals x, that says y and x are the same. So where I see a y, I convert it to an x, so I just have one variable. We know this is a unit circle, so I know my radius is 1. So I get 2x squared equals 1. X squared equals 1/2. Doing that crazy algebra, I'm solving for x. I square root both sides. If you remember, I said when you square root, you always do plus or minus. However, I know that my x value, I can tell by looking at this, because I'm in quadrant 1, is going to be positive, so I don't worry about the negative value. Then if you remember with radicals, you can do this, right? You can split the square roots. The square root of 1 is just 1. And then I rationalize the denominator. So I get x equals the square root of 2 over 2. And we said y is the same thing. But wait, there's more. So now I can find the value of my 6 trigonometric functions based off of, now I have a point. All right, so I'm on the unit circle. My angle is pi over 4 or 45 degrees. I now know the values of that point. So now I can very quickly, because we remember these, right? The sine is the y value. Ba, 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 ba. The cosine, the x value, ba, 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 ba. The tangent is x over y. Well, if I take, I'm sorry, I said x over y. Y over x, teacher mistake. Ba, la, la. That's just 1, right? You're just dividing the same thing. The cosecant is 1 over y. See if I can get this to fit. And so that becomes 2 over the square root of 2, because I brought the square root of 2 up. And then I rationalize the denominator, la la la, and I get that. And how lovely those, well, I missed the 2, cancel, so I get square root of 2. The secant is 1 over x. Well, these are the same values. Okay, so secant, cosecant's the same. The cotangent is now what I said wrong with the tangent. So the tangent was y over x. The cotangent is x over y. Well, they're still the same value, so you simply get 1. So this allows me now, I have another angle. So I have 0, 90, 180, 270, technically 360, right? Or any multiples of those values. And I also know how to find 45 degrees. So let's move on. What if I want to find 60 degrees? So if I take and make an equilateral triangle, boy, those geometry days are coming back to haunt us, right? Which says that this side, which is a plus a, which is 2a, equals my other side, 1. And so that says a equals 1/2. So that's my value of a, which, as you're going to see, if this is on the unit circle, that's going to be my value of x. Well, how do I find b? I'm so happy you asked. There's that dude again, right? That says a squared plus b squared equals c squared. I just found for you so nicely a b squared. And I know c is 1. So I can take and solve this. So I'm going to get 1/4 plus b squared equals 1. B squared equals 1 minus 1/4. B squared equals 3/4. And now I have to square root. So b equals the square root of 3 over 4. Once again, I can separate these. And voila! That's how I actually got that value. I mean, I'm kind of going through this stuff pretty fast because you're just going to memorize these values, okay? Or you're going to have a chart that you're going to look them up. But that's how we get the y value. All right, so based on that, if I have an x and I have a y, guess what? So my angle, my theta, 60 degrees or pi over 3, corresponds to the point on the unit circle, 1/2 square root of 3 over 2. So if I want to find the sine of 60 degrees, I take my y value. If I want to find the cosine, I take my x value. If I want to find the tangent, I take my y over my x. And once again, of course, the 2's are going to cancel, so I just get square roots of 3. If I want to find cosecant, that's 1 over the y value. So the 2 comes up there, rationalize, 2 square roots of 3 over 3. The secant is 1 over my x, so 1 over 1/2. The 2 comes up top, so nicely. And then my cotangent is my x over my y. So once again, the 2's cancel, and I rationalize the denominator, and I get my value. So based off of those nice little triangles, I could find the values for 60 degrees. Well, the same thing happens with 30 degrees, because if you remember, this angle right here is 30 degrees. We'll just flip this triangle. And so that's what I did right there. And guess what also flips? The x and y values. All right, so take a deep breath and be sure you're okay, that you understand this, that all I've done is I've said, well, now this is my 30-degree angle, that's my 60-degree angle. So if you actually sit there and watched it rotate, then you would see that the y value that was here comes here, and the x value goes there. So once again, I can find all of these values because the sine is the y, the cosine is the x, The tangent is the y over x. Somebody's calling me, probably not important, huh? And so the 2's cancel, so 1 over square root of 3 times square root of 3 over square root of 3 equals square root of 3 over 3. The cosecant, which is 1 over the y value. The secant, which is 1 over the x value. Probably you've noticed that you could just go copy the matching ones with the 60 degree. So this becomes 2 over square roots of 3, and you see which ones are switching with the 60 degrees. So 2 square roots of 3 over 3. And then finally, I get x over y, and so that becomes the square root of 3. So nicely, now I have my quadrantal angles, I have my 45 degree, and then I have my 30 and 60 degree. And you're going to see those are important ones to be able to solve a lot of these problems. I can look at multiples of these, because notice if I have that line y equals x, and of course this would be y equals negative x, then I can just reflect. Remember we talked about in the review about reflecting these points? Well, I know if I reflect that, the y didn't change, so it's the same. I can see that the x value went negative. Same thing here, the x value stayed the same, but the y went negative, and when I reflect across the origin, both of them go negative. All right, so I want to find the cosine of 5 pi over 4. The problem is I don't know where 5 pi over 4 is, so let's kind of go down here. So the cosine of 5 pi over 4. You can do this kind of a few different ways. Most students, as I have found, prefer to think in degrees. So if this needs to be in degrees, how do you do that? I heard you yell at the computer. You multiply it by 180 over pi. You remember that, right? And so you should get, that goes 45 times. And so the pi's cancel. And 5 times 45 would be 225. So that would be this point right here. Why? Because that's taken me to 180, and then that's taken me to 225. Now I know you're going to say, but hey Cindy, you got the answers right there. But I want to be sure, what if I just gave you that on the test and I didn't tell you where 5 pi over 4 was? So by looking at this angle, I can see that the cosine is the x value. Good answer. So negative square root of 2 over 2. All right, the sine of 135 degrees, if I'm at 90 and then I add 45. So this would be the sine of 135 degrees. The sine is the y value, so square root of 2 over 2. All right, now I want to find the tangent of 315 degrees. Well, I know if I go all the way around here, I'm at 270. Okay, so at 270, if I add 45 more, that gets me to my 315 degrees. We said that the tangent, so I'm looking at, is my y over my x, so you can see those cancel and give you a -1. All right, and so the last one, just have to be careful. This is a negative value. So the sine of negative pi over 4. Pi over 4 was going this way. Negative pi over 4 is going this way. So the sine, being the y value, would be negative square roots of 2 over 2. All right, moving right along, let's look at integer multiples of 60 and 30 degrees. So we're going to do the same thing once we have these integer multiples. 210, I have to figure out, well, what's that a multiple of? Well, I know this is 180, And then if I add 30 here, okay, so I know it gets me to that point. So based off of looking at my picture here, you can see, and I already kind of show you, but you can see that this is the 60-degree one, and this is the 30-degree one. So it depends, are you in multiples of the 60? Are you in multiples of the 30? So if I'm looking at cosine of 210, the cosine, if I'm looking at 180, and then I'm looking at 30, well, in this case, I just said this one's 60, so I'm looking at the wrong graph. So 180, and then you add 30. So be sure you're looking at the right graph, right? And so based off of cosine x value, sorry, that's kind of hard to see, but there is a little square root right there. All right, negative 60 degrees. I know where the 60 graph is now. Negative, I'm going this way. Sine is my y value, so would be that value. My tangent of 5 pi over 3. Okay, so you can see 5 pi over 3 here. The tangent, so, is going to be my, and that's a negative y over my x. And so negative square roots of 3. And then finally the cosine of 8 pi over 3. Well, I look at all of these things going on here, and I don't see an 8 pi over 3. I'm kind of figuring that it's on this graph because these are all over 3. So if you're not sure, once again, what do? Why not change this into degrees to figure out what's going on? And so 3 goes into 180, 60 times. So this is actually 480 degrees. Well, if you go all the way around the circle, you've gone 360 degrees, right? Right. And so that means you have left over 120 degrees, okay? So I have to figure out where 120 degrees is. Well, I know that's a multiple of my 60, so 90, and then I add 60. No, that doesn't seem, does that seem to work? Why'd I say 60? Notice if this piece here is 60, okay, then this piece here is 60. This little right here from the 90 to that point is actually only 30. So that would be my 120. If you're skeptical and you don't believe me, what's 2 pi over 3 in degrees? Like I said, students seem to just like, they think better, right, in degrees. And so I can clearly see that's my 120, and I'm looking for what cosine, so I get my value. All right, good, what slide? Yeah, good stopping place there. The last lecture will be a little shorter, but I kind of like to keep these around 20 minutes. So see you in the last lecture. Be sure and practice these. Once again, you're going to see that probably the biggest part is first learning the 45 degrees, the 60 degrees, the 30 degrees, and then you can find anything based on those multiples, based on reflecting those points. So I see you next lecture.